Do you ever get math problems wrong because you missed a minus sign or canceled terms incorrectly or added something to one side of an equation but forgot to add it to the other? Or maybe you just multiplied numbers incorrectly. Careless mistakes, or as my younger son calls them, kick me mistakes. It's okay. Everyone makes these kind of mistakes from time to time. But do they seem like they happen more often to you than you'd like? The good news is, most of these kind of mistakes can be prevented with good math organization, which is something they don't usually teach in school for some reason. But if your teacher sent you this video, you're in good hands. For the rest of you, that's okay. You're here. I got you covered. So stick around, watch this video, and learn how to better organize your math problem solving to reduce the number of kick me mistakes that you make. Good math organization is really just a set of techniques that help you follow what I call the golden principle. Don't work your brain too hard. The careless kick me type mistakes that my kids made in elementary school, and the ones they make now on occasion in middle school, and even the ones I used to make as a math major in college and grad school, these mistakes are almost always due to some violation of the golden principle. So I came up with a set of rules to help my kids follow the golden principle when solving math problems. So enough with the introduction. Let's dive in. Rule number 1, avoid doing work only in your head. Always write it down. Why? Writing down your work serves as an extra sanity check to make mistakes much less likely. Writing your mental work down also allows you to more easily follow your reasoning later on if and when you check your work. But if you do work only in your head, how do you find a mistake later on? That is, how do you check the work that you did only in your head and forgot by the time you come back around to check your work? That would require a lot of brain work, right? Then that's a clear violation of the golden principle. So stop doing work only in your head and put it all down on paper. Now you may be thinking side work for arithmetic and such, and yes, I am talking about that, but another lesser known example here is to always start your work at the beginning by copying down the problem, at least when you're given something you can easily copy. Then take a few seconds to ensure you copied it correctly. That's your starting point. Never have the first thing you write be some simplified version of the problem based on work you did in your head. Start at the beginning and write down the problem to be solved in its original form first. Let's look at a simple example to see this in action. Suppose your teacher gave you this problem in a PDF file she emailed to the class, or a Google Classroom assignment, or whatever, and you're supposed to do the work on paper, then take a photo of your assignment and upload it to the teacher to review, since that's how a lot of school homework is done these days. Anyway, you see this problem and you say to yourself, hey, there's an obvious simplification I can make as a first step, so I think I'll do that simplification in my head, then start with the easier problem. So you do just that. You divide both sides by 2, so now you have x minus 4 equals 28, and so you work the problem, add 4 to both sides, and now you get x equals 32. And you can easily check that because x minus 4 is 32 minus 4, which is 28, right? Must be correct. You probably noticed the issue, but in case you didn't, the mistake was in the very first step, the one where I did math only in my head. I divided 58 by 2 in my head and got 28 instead of 29. Then I made a second mistake by checking the answer against that wrong equation instead of the original equation, so the check gave me the false impression that I was correct. Now obviously, you may not make this particular mistake on this particular problem, but I have personally made this kind of mistake many times myself, and I've seen my kids make it several times as well. If you do work only in your head, it's really hard to find the mistake. So don't do that. If I had instead started by copying down the original problem and checking to make sure I copied it correctly, then performing the division of 58 divided by 2 as long division in the side work, instead of doing that division in my head, I would have almost certainly been successful. But even if I made a mistake, I would have checked my wrong answer against the original equation, which would have likely shown me that I messed up somewhere. So avoid doing math only in your head. Start from the beginning and write everything down. Rule number 2, when working on a problem, prefer going down the page line by line and not across. Why? It's easier on the eyes. Just take this problem as an example. If I try to work this one by going to the side, notice I'm having to constantly look back across lots of stuff I don't care about to find the thing I do care about, then take my eyes back to the proper spot to write down my next move, and again, and again, and again, and again. This is hard on the eyes and the brain, and it's just asking for a mistake. However, if we go down the page instead of across while working the problem, it's a lot easier on the eyes since things naturally line up. So it's much easier to keep track of things, and we're much less likely to make a mistake. Remember the golden principle? go down the page, line by line, not across. Your brain will thank you. If it helps to remember this, yes, no. Got it? Good. Rule number 3, line up terms when going down the page. It's a lot easier on the eyes and the brain. If you don't line them up, you'll be using brain cells to figure out where stuff goes in addition to using brain cells on the problem. And that's a clear violation of the golden principle. So line up your terms as you work the problem. This also means you should line up your equal signs or inequality signs as you work the problem at least as much as possible. As an example, let's solve for x here. Now if you haven't gotten to solving quadratic equations in school yet, that's okay. Just watch how I line things up since that's what's important. So let's say we decide to add 3 to both sides, so we do that. Then let's say we add 3x to both sides, so we do that. Then let's say we subtract 12 from both sides, so we do that. Then let's say we divide both sides by 2, so we do that. Now we have an equation that's not easily factored, and completing the square would be ugly too, so let's brute force it with the quadratic formula. And we have solutions of x being 2 and minus 3 halves. Now you may have spotted my mistake here, but my point in doing this is to show just how easy it is to make a mistake when you don't line things up. Reworking the problem, lining things up properly, makes the mistake much harder to make. And it also just makes the problem plain easier to solve. So let's take another crack at this problem, but this time let's line things up properly. So we decide to add 3 to both sides. So we do that, but notice this time I'm putting the 3's under the numbers to which they'll be added. This makes it harder to screw up the addition. Let's continue by adding 3x to both sides, so we do that by lining up the 3x right under the x terms, unlike last time where I placed 3x under the x squared term, which led to my mistake. Now let's subtract 12 from both sides like last time, which results in a much easier quadratic equation since this one is easily factored. We get the possible values of x being 3 and minus 4. Lining things up where they should be sets you up for success and just makes the problem plain easier to solve. Not lining things up makes your brain have to work harder to keep things straight, and that's a violation of the golden principle. So do yourself a favor, line things up when working a problem. Rule number 4, when in doubt, do one operation per line. It's easier on the brain to keep track of one thing at a time, and it's harder on the brain to keep track of lots of things at one time. So don't do that. Keep it simple. Besides, it's much easier to check your work later on if you only have to follow one thing that changed on each line, right? Okay, I admit doing this will require more writing and even more hand cramps, but it will also result in fewer mistakes since you're not doing too much work at any one time. Focusing on one thing at a time helps you adhere to the golden principle. Let's look at this problem as an example. Simplifying this expression one step at a time does take a while, but it also makes it much harder to make a mistake at any particular step. On the other hand, if you attempt to do several steps at a time, it could very well go something like this. Again, I'm not saying you'd make this particular mistake on this particular problem, but mistakes are more easily made when you do many things at once versus one thing at a time. So when in doubt, especially when simplifying, do one thing. One operation, just one simplification at a time. Rule number 5, put your side work on the side. You know from rule number 1 that you should write down your side work, right? But writing down willy-nilly just anywhere can be confusing. So break out your side work on the side, wall it off with a line, and label it side work. Why? It helps avoid confusion caused by mixing side work in with your direct work. Side work generally consists of things like factoring, simple arithmetic, or anything else that's needed to work the problem but isn't directly part of the problem. So don't put it directly in the line of solving the problem. Put it off to the side. Let's take this problem as an example where you have to solve for x. Now, it may jump out at you that 299 is a weird number to see in a problem like this, so you may be wondering if it's divisible by 13. So you do some long division as side work off to the side to show that 299 is in fact 23 times 13. Then you go back in working the problem, easy peasy. X is negative 2 over 23. If, on the other hand, you do side work in line, you can make the problem harder. What's this long division doing here? It's harder to follow your direct work, especially when checking your work since your brain is in simplification mode on each step. It's thinking simplification, 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 then it hits a long division? What's that doing there? More technically, that's a mini version of context switching, which can throw you off and make the problem harder to follow, which makes the brain do more work than it should, which is a violation of the golden principle. True, this is a simple version of this, but the higher up you go in math, the more complicated the problems become. and the more side work is involved. Besides, what if it turns out that 299 wasn't divisible by 13? You'd have put a long division in line that doesn't help in any way in solving the problem, which is even more confusing. And what do you do then? Erase? Put a bunch of smudges all over your paper? Do you start over? Do you cross it out? No, just put your side work on the side. If it doesn't work out, who cares? It's in the side. Now, some of you may be wondering how you'd be able to follow that 299 all of a sudden became 23 times 13 without the side work in line. In this case, use parentheses. Put parentheses around the 299, parentheses around the 23 times 13, letting you know those two things are the same thing. Another technique is to use labels, like a number 1 in the side work, circle the number 1, and then put the circle number 1 over here in your work. So you can reference number 1 and go, oh, this 23 times 13, look over here at this long division. Oh, that's how that is what it is. And then you can have a number 2, a number 3 for really complicated problems, or ABC, or stars and moons, I don't care. The point is, you can label things if for really complicated things to say, hey, this step right here is due to this step over here in the side work. Capiche? But I digress. My point here is that you should not try to interrupt the flow of work in a problem with side work in line. Break out side work on the side. And for more complicated problems, consider labeling parts of it as needed for reference. Number 1 goes to number 1, number 2 goes to number 2, that kind of thing. Moon, cow, chicken, I don't care. You do you. Rule number 6, use horizontal lines for fractions. They make everything easier. You can still use slashes when cooking, but keep them away from math assignments. As for the division sign, well, those are a relic left over from days when typesetting was difficult. Back when folks used the Gutenberg printing press up through the typewriter. But those are all replaced with word processors in the mid-1980s. Today, these old school division signs aren't used after like 5th grade, and honestly, I'm not sure why we're even using them up until then. Do elementary school teachers still use typewriters with a division sign in them? Besides, the division sign is just plain confusing. Look at it. It looks like a fraction. So why not just write the fraction? Just get rid of the dots, put the first number on top, the second number on bottom. It's easier. It's less confusing. I digress. Let's look at the same problem written 3 different ways. You tell me which is easier. To solve it using horizontal lines fractions, you can start canceling numerators and denominators and solve it fairly easily. It's 4. But with the cooking slashes, it gets more confusing how to cancel terms, which makes the brain work harder than it should, which is a violation of the golden principle. Written this way, I think I can cancel maybe the first 8 with the last, and the last 2 rather, with the 16? Then, my brain hurt! It's not as easy, is it? And just to torture ourselves, let's look at the same problem with the division sign. This goes beyond just violating the golden principle. It's an abomination, seriously. What are you supposed to do with this? It's ambiguous, to put it diplomatically, and the only way to make it less ambiguous while keeping the division sign would be to add a bunch of parentheses, which still doesn't make it very easy to work with. This is a blatant violation of the golden principle. So in short, avoid cooking slashes when possible, but avoid the division sign like the plague. When doing actual math, use horizontal lines when writing your fractions. They make life much easier. Rule number 7, prefer improper fractions to mixed numbers and try to avoid decimals. Okay, I know, the scientists and engineers out there are probably rage commenting as I say that. Hear me out. You're probably saying something like this. In the real world, we have to use decimals because we measure things and end up with decimals. I agree. In the real world, things are measured to the precision of the measuring device, like a ruler or a scale, which results in a decimal with the last digit being what's known as a significant digit, which presents a whole world of issues when doing math, which only serves to prove my point. Decimals make math difficult. So let's retreat back to the perfect world of pure math, where everything is exact and beautiful, like me. In this world, problems are almost always easier with improper fractions, and nearly everything is harder with decimals. Mixed fractions are fine to start or end with, but are hard to work with, so you'll usually want to convert them to improper fractions. Let's look at the same problem solved 3 different ways using improper fractions, mixed numbers, and decimals, and you tell me what you think. and some reuse improper fractions, they make the math easier. Rule number 8, write clearly to avoid confusion. Now that should be obvious, but what if you're like me and you have horrible handwriting? Then it's a serious challenge, so slow down and write clearly. Now there are two things related to this about writing clearly. You don't want to write things that can be easily confused for other things. For example, if you're working with variables, don't use a time sign since it can be confused with the variable x. Use a dot or parentheses instead. Similarly, consider putting slashes through your z's and zeros to avoid confusing them with 2's and o's. Perhaps consider using cursive i's to avoid confusing them with 1's. That sort of thing. Come up with your own system. You just don't want to confuse some things with other things, right? Second, avoid erasing things. Or if you do erase, invest in one of those stick erasers that erase really, really good and make sure you erase completely. Why? Because when you don't erase completely, you can have smudges and other things that can be confusing. I personally like to just cross things out instead of erasing to avoid this confusion. It's also faster. The point of all this is you want your brain working on the problem, not trying to figure out if something is a 1 or a 7, a 2 or a z, a minus sign or a smudge, that sort of thing. Writing clearly helps eliminate these sorts of issues that otherwise violate the golden principle. Rule number 9. Give your work a quick sanity check, just a few seconds right when you finish a given problem. Now what do I mean by a sanity check? As an example, let's say you're figuring out how far a car going 60 miles an hour in the same direction will travel in 4 hours. Well, just think about it. That's about highway speed, right? How far can you travel in 4 hours on the highway? 200 miles? 300 miles? Maybe you guys in Montana can go like 400 miles? Something like that, yeah. So if your answer is 24 miles or 2400 miles, you know right then and there that you screwed up. So go back and see where you messed up. Even in more complicated examples like the area under the curve in calculus, you know it's boxed in by a triangle which has an easily computed area, so you can compute the area of that triangle and say, well, it's got to be a little bit less than that. So if you end up being more than that or way less than that, you know you probably screwed up, right? Basically, if you can visualize it, then you can do rough estimates around what the answer should be, and if your answer is far off from that, then you should go back over your work right then and there to see where you messed up. And here's the cool thing. If you wrote everything down, even your side work, and you went line by line, you kept things lined up, and you did one thing at a time, and you wrote clearly, in other words, you followed the rules, then it's easy to follow your work, so it should be straightforward to check, and the mistake will most likely just jump right out at you. Rule number 10. For time tests in particular, but also homework or anything else is graded, go back and check all of your work after you finish the assignment with any time you have remaining. Here's the key. To check your work, you probably need some room to check it, right? So as you're working problems, you should leave some room between the end of one problem and the start of the next problem so you can use that space to check your work later on, if it's the kind of thing that can be checked at least. So let's look at our quadratic problem. Let's say this is a time test, you're done early, and you have time to go back and check your work. That room can be used for just that. Label it check, wall it off, and use the space to check your work. Yes, I know. It's an awesome feeling to finish a test early and turn in your work ahead of most everyone else in class, but here's the key point. The math doesn't care. If you finish early yet made a kick-me mistake that you would have caught by checking your work, those are points you left on the table and you'll be kicking yourself for it later. Don't leave points on the table. Check your work. Now I save these last two rules for the end only because they have more to do with mindset than organization, but I believe they're the most important rules of all. Ready? Rule number 11. Calm down, take a deep breath, and slow down. People make careless mistakes when solving math problems too quickly. Going too quickly can make you think 2 steps ahead and not give enough attention to the step you're on, and then bam, you make a careless mistake. To do math well, it helps to be more like a calm, tea-drinking chess player. Calm and methodical. Take your time. Go at your own pace. Now I know this runs counter to what most math teachers in grade school emphasize. They want you to work quickly. They love giving timed tests, and they want to see how many problems you can complete in 10 minutes. And some teachers even have contests where the kid who solves the problem fastest wins. Yay! But the thing is, you'll get faster naturally at most anything you do a lot. Whether it's running a mile, mowing the lawn, writing an essay, most anything in life. The more you do something, the better you get at it and the faster you can do it. There's no need to practice speed in math. Speed will come naturally by doing math. You use arithmetic and algebra, right? So you get extra practice in your arithmetic there. Calculus is the same with algebra. It uses a lot of algebra, so you get a lot of practice with algebra, which in turn gives you a lot of practice with arithmetic. But having kids learn to do something quickly unnaturally just leads to a lot of anxiety, a lot of wrong answers, and a hatred of math, which doesn't do anyone any good. Besides, and this goes to you teachers out there, if you really want kids to do arithmetic quickly, then you wouldn't allow calculators later on. I mean, you have to admit, it's kind of a mixed message. Hey, fifth graders, you need to be able to do arithmetic quickly, so memorize your math facts because we're going to have a lot of timed tests on them. Hey, sixth graders, here's a calculator you can use for arithmetic from now on. Really? By using the calculator, they're going to rely on that and forget all their arithmetic because they're not doing it anymore. So don't do that. Anyway, I digress. Again, so back to the speed thing. Take it from me, someone with a bachelor's and a master's degree in mathematics who worked as a professional software developer for over 20 years and doing anything logical. But more to the point here, math, it helps to remain calm and go at your own pace. Because in real math, as with any logical endeavor, quality counts way more than speed. Think about it. Do you want your accountant to do your taxes extra quickly, or do you want him or her to take enough time to ensure that they're done correctly? How about your local civil engineer who's designing a bridge you'll be crossing every day? How about the electrical engineer who's designing the next generation electric car battery? How about the software developer writing, well, most anything you use on your phone or computer? Do you want any of these folks to go fast, 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 or do you want them to slow down a little bit and make sure they get things right? Exactly. Professionals go only as fast as they can and still get it right. Now, they do have deadlines and other factors making speed important, but not at the cost of getting things right. Why speed is emphasized in grade school, I don't know. But do yourself a favor when doing math. Take a deep breath, calm down, and slow down. You'll make a lot fewer mistakes when you do, and in the long run, that's what's important. I mean, that's why you're here, right? And the last rule, rule number 12, look at mistakes as learning opportunities. When you get a graded assignment back, study each mistake you made. For a given mistake, ask yourself, why did you make this mistake? Were you going too fast? Did you do arithmetic in your head that should have been written down as side work? Did you confuse a smudge for a minus sign? Whatever the reason, take a mental note, or better yet, write it down in a journal. Then try to avoid making the same mistake again. Oh, don't worry though, you will make that mistake again. But the more you notice what leads to your mistakes, the more conscious you are about how to prevent them, and you're going to catch yourself if you're making that mistake. You're going to go, oh, hold on, let me not make that mistake, because you know you tend to make that kind of mistake. And pretty soon, you're not really making that mistake much, if ever, anymore. As you may know from history, if you don't study history, you'll be doomed to repeat it. It's similar here. If you don't learn from your math mistakes, you'll be doomed to repeat them. So look at your mistakes as learning opportunities. That's all I have, but what about you? Do you have any tips that can help math students avoid careless mistakes? If so, drop a comment about it below. As always, I hope this helps, and thanks for watching. Cheers!